All right, hey guys, it's Miss Johnson here, and I am here to give you your notes video for Unit 9 Notes 2. And we're going to do a little practice today, refresh our memories on multiplying and dividing monomials and also factoring. So that's what we're looking at for our notes today. Our lesson objectives are I can simplify monomials using multiplication and division, and I can factor expressions. So let's just take a look at some monomial rules and remind ourselves what's happening with these monomial rules. When we multiply like bases, this is also called the product rule. Purple's kind of hard to see. Product rule. When we're multiplying things with like bases, we need to add their exponents. And for an example, if we had a to the 6th times a to the 3rd, that gives us a to the 9th. Okay, if we're if we're looking at a power of a power, when we have a power outside of a power, we need to multiply exponents. And for example, if I had 6a to the 6th to the 2nd power, 6 squared is the same thing as 36, and a to the 6th to the 2nd, that's where I'm going to multiply those, and 6 times 2 is 12, so that's a to the 12th. For the 0 power, anything that's raised to the 0 power is equal to 1. So if I had 1,000 times a to the 3rd, 10,000 times a to the 3rd, all raised to the 0 power, that's simply equal to 1, because everything inside is raised to that 0 power. And then if we're dividing like bases, this is also called the quotient rule. When we divide like bases, we need to subtract their exponents. So for an example, if I have a to the 6th divided by a to the 3rd, I take a to the 6 minus 3, which is a to the 3rd. Another way of looking at that is if you had 6 a's, 1, 2, 3, 4, 5, 6, yep, and then I have 3 on the bottom. We all know that anything over itself is 1. So if I have a divided by a, that's 1. It cancels out. A divided by a again cancels out. A divided by a again cancels out. I've gotten rid of the whole denominator, and I'm left with just a to the 3rd on top. Now, one that I forgot to mention or forgot to put on your table, and that's my fault, is the negative exponent. So see if you can find a little white space on your notes. So if we have a negative exponent, what we have to do is we have to move the term's position, and then we make the exponent positive. So move positions and make exponent positive. An example of that, let me get rid of this. An example of that would be, let's say I had 1 over a to the negative 2nd power. That a to the negative 2nd power, we're not going to keep a negative 2 power. So I need to take that and move it up here. And it becomes 1 times a to the positive 2nd power, which is just a to the 2nd power. Okay, so that's just a review of our rules. Those are back from Unit 3. So if you don't remember what we did in Unit 3 or you need some help with that, you can go back to those notes videos and rewatch some of them or look back at your notes in Unit 3 and see if you can help yourself out to refresh your memory. Let's do some examples. The first example, I have 4 times x squared times y to the 3rd. Now, like bases, I need to look for the things that are going to be in common. So in this case, I have an x and an x. So 4 times x squared times y to the 3rd. I can put those two together. This is x to the 1st. So x to the 1st times x to the 2nd, I need to add their exponents, which is 4x to the 3rd, y to the 3rd. Okay, so that's that one. Let's look at number 2. In number 2, I have a whole bunch of stuff raised to the 0 power, 4x, y, z to the 3rd, and it's all being raised to the 0 power. Since it's all being raised to the 0 power, the whole thing goes away and is just 1. Let's take a look at number 3. Now I have a whole bunch of stuff being raised to the second power. So I need to take everything that's inside and raise it to the second power. So that means the second power goes to the 6, it goes to the y, it goes to the x to the third, the y to the fourth, and the x. So I'm going to start with that. 6 squared is 36. Y to the second is y to the second. X to the third to the second, I need to multiply my power, so that's going to be x to the sixth. Y to the fourth to the second, again, I need to multiply my power, so that's going to be y to the eighth. And x to the first to the second, 1 times 2 is 2, so that's just x to the second. Now I have to check if there's any more simplifying. I can put my like bases together. So I have x to the sixth and x to the second. That's 36x to the 8. Remember, when we multiply those, we add them. Multiply the powers, we add the exponents. Same thing with the y's. I have y to the second times y to the 8th. I'm going to add the powers, which gives me y to the 10th. So I have 36 x to the 8th, y to the 10th. Okay. I want you to go ahead and actually let's look at number 4 together. We'll look at number 4. In number 4, I have 2 inside, all raised to the third power, then the second power, then the second power. So what happens here is I need to multiply all 3 of those. So I really have 2 to the 3 times 2 times 2 power. Well, 3 times 2 is 6, and times another 2 is 12. That's the same thing as 2 to the 12th power. And if we plug that into our calculator, 2 to the 12th is equal to 4,096. Okay. I want you to go ahead and pause the video at this time and see if you can do number 5 on your own. So try number 5, see if you can simplify that one. And let's take a look at number 6. See if I can get rid of all my stuff here. Slide everything up a little bit. Pull out number 6, here it is. All right, I have 3xy to the fourth times negative 2y to the second to the third. So lots of things that I have to do to simplify here. The first one is I need to multiply the powers over here. I have this raised to the second and raised to the third. So I'm not going to do anything with the first one yet. 3xy to the fourth. That term's just going to stay the same for now. Then the second set of parentheses, I'm going to multiply those 2 powers. So that's negative 2 y to the 6th power. So I need to take everything inside to the 6th power, negative 2 to the 6th power, and y to the 6th power. Now, negative 2 to the 6th power happens to be 64. Yes, so I'm looking at, again, I haven't touched that first term, so 3xy to the fourth is still there. Then I have positive 64 y to the sixth. Now I can put my like terms together. So I'm going to multiply the coefficients. 64 times 3 is 192. So I have 192. The x is by itself, so that's just going to stay x to the first. And y to the fourth times y to the sixth is y to the 10th. So I have 192 times x times y to the 10th. Okay, now let's look at some division with these things and do some practice there. In number 7, I'm looking at 4ab divided by a. 4ab divided by a. Now remember, when we divide the like bases, I need to subtract their exponents. So what happens for this one is I get 4 times a to the 1 minus 1 power times b, because this a to the first, that a to the first, I'm subtracting their exponents. Well, 1 minus 1 is 0, so essentially this whole term goes away, and I'm left with just 4b. You could also think of that as I have a over a, and any number over itself cancels out. So a couple of different ways to look at that one. But either way you look at it, our final answer there is 4b. Let's take a look at number 8. In number 8, we have 4b to the negative third over a to the negative second. And again, when we have negative exponents, I need to switch their positions and move them up. So we'll go yellow here. So that means the a to the negative second is going to come up there, and the b to the negative third is going to go down there. And what that looks like is 4a to the positive 2 over b to the positive 3. So 4a squared over b to the third, and then I need to look and see if there's anything else that I can simplify. There's nothing else that cancels out, so that's just my final answer. As long as I have no more negative exponents in there and I've done all the simplifying, then that's all I can do. I want you to take a second here and see if you can work on number 9. Complete number 9 on your own time. And let's take a look at number 10. So in number 10, again, I start with those negative exponents. I'm going to see what negative exponents I can switch positions. This q to the second needs to go down, that r to the negative third needs to go up, and the s to the negative fifth needs to go up. So here's what I have. The negative 3 stays there. Then I have r, which was already there. I moved the r to the negative third up, which became r to the positive third. And I moved s to the negative fifth up, which becomes s to the positive fifth. In the bottom, the negative 12 I haven't touched. And then I'm going to keep the q that was there raised to a positive power. I'm going to bring the q to the negative second down. So that's q to the positive second. And now I've moved everything that needs to be moved. Now I'm going to go back and look at what I can cancel. The coefficients. First of all, negative over negative, positive. Done with them. The 3 over 12, I can divide both of those by 3. If I take out the common factor of 3, this becomes a 1, and that becomes a 4. 12 divided by 3 is 4. And now put your like bases together. R to the first times R to the third, that's R to the fourth. S is by itself, S to the fifth. And Q to the first times Q squared on the bottom is Q to the third. So let's put it all together. I have R to the fourth times S to the fifth on top. On the bottom, I have a 4 coefficient Q to the positive third. I've simplified everything that I can simplify. There's no more negative exponents, and that's my final answer. That's going to conclude our video for today. Thanks for watching, and we will see you tomorrow.